So today here we are gonna prove the equation of motion in simple physics, right? Practically, and all you need to prove this equation is one ball. So what we are gonna do basically is drop the ball from this height, and we are going to calculate the time required to hit the ground for the same. And after calculating the time, it's all easy that we know it's accelerating by the gravitational acceleration. So we are going to take our g. So at the end you will get height of this wall purely by the our equation of motion, and we are also going to calculate it by using a measuring tape. So let's get started. So we are going to take 3 readings for our hand-eye coordination convenience. It will give you the average accurate reading. So ball, I should give it the 0 speed. That means I shouldn't accelerate by my hand because it should have to fall down only due to the gravitational acceleration. So it will give the right reading. So 3, 2, 1. 3, 2, 1. 3, 2, 1. So these are the 3 sets of reading that we have taken, and we are going to take its average value. So these are the 3 equations of motion you are looking here, and according to the parameter that you are going to calculate, you can select any one of them. So in our case we are going to select the third one, as we are going to calculate the height of wall. So we are going to take the third equation here. So here you can see the meaning of each term. S is for the displacement. Here in our case it is the height of wall, and our final answer. And equals ut. U means the initial velocity, that as our ball is at the rest on my hand in our case, so initial velocity u is 0, and t is the time required for the ball to hit the ground. And a here, the acceleration, is in our case the gravitational acceleration, as we are going to drop the ball from the height. So it's g, gravitational acceleration, equals to 9.8 meter per second square. And simply just solving the equation further, you will get the answer, which is 4.1 meter, which is calculated by the equation of motion. And let's see what comes by measuring the actual using the measuring tape. So here's my colleague, and so we are simply going to prove the equation of motions, the 3 main equations of motion, right, practically. So to measure the height of the wall. So as you can here see, from the ground to this one is around the 14 feet, or the 4 meter to 170 millimeters height, that measured by the tape. Here you can see the comparable difference between the 2 readings measured by the actual tape and the calculated by the equation of motion. So the answer calculated by the equation of motion is 10 centimeter less than the actual one. This is because when ball was falling down, it has experienced the aerodynamic drag in an upward direction, so it slows down its speed in actual. So we haven't considered this in our equations.